so 7.8 is on adding and subtracting rational expressions. So we did multiplying and dividing. Adding and subtracting can be a little bit more complicated, a little bit harder, specifically when you don't have like bases. So the same rules apply when you're just adding and subtracting regular fractions. You have to have like bases or like denominators. So we're going to check those denominators and see if they have a common denominator. If they do, it's pretty easy. If they have a like base, we combine the numerators. So you add or subtract the numerators, but your denominators stay the same. You don't add them, don't subtract them, you just carry it over. And then we simplify. So once we've added and subtracted, we simplify. So we do our factoring and canceling out, that sort of thing. So number 1, do we have like bases or common denominators? Yes, they're both 4x squared. So we're just going to add straight across. What is 13x plus 5x? 18x. And then the denominator stays 4x squared. So then we'll need to simplify that. What is 18 over 4? 9 over 2. And you can just type in the fraction 18 over 4 in your calculator. Go to alpha y equals and type it in and you hit enter. And then x over x squared. When we simplify that, how many x's are left and where are they? 1x on the bottom. Good. So 9 over 2x is our answer. Number 2, do we have like denominators? Yes. So the bottom is just going to stay 16. Are we adding or subtracting here? Subtracting. So you have to pay attention. We're subtracting 7x and we're subtracting 2. So we have 9x minus 7x, which is 2x, and then 12 minus 2, which is 10. So we have 2x plus 10 over 16. Do we have a GCF in this numerator? 2. So we're going to factor out the GCF of 2, which leaves us x plus 5 over 16. And then we can simplify this 2 over 16 to 1 over 8. So this would be x plus 5 over 8. Number 3, we have like bases or common denominators. So when we add, that's going to stay x squared minus 9. And this is an addition problem, so we're adding the numerators. The only like terms that we have are this 8x and 2x. That's going to become 10x. So x squared plus 10x plus 21. Can I cancel out these x squareds? No, because there's something being added to that. So x squared is not its own factor. For you to be able to cancel out things, you have to have their own factors. Anytime something is being added, it's not its own factor. So we have to completely factor before we can start canceling out. How does the bottom or the denominator factor? It's difference of squares. So that becomes x plus 3, x minus 3. The top, this is a trinomial, so you're looking for two numbers that multiply to be 21 and add to be 10. What are those two numbers? 7 and 3. So we have x plus 7, x plus 3. Once everything is completely factored, then you can cancel out. You cancel out entire factors. So this x plus 7 is an entire factor. This x plus 3. So I can cancel out these x plus 3's, leaving x plus 7 over x minus 3. Number 4, we have like bases, 12x minus 3. And the numerator is a subtraction, so it's just 1 minus 16x squared. Is there a GCF in the top? No. So how does that one factor? It is also a difference because they're subtraction of squares. What's the square root of 1? What's the square root of 16x squared? 4x. So it'll be 1 plus 4x and 1 minus 4x. Is there a GCF in the bottom? What is it? 3. So 3 and then 4x minus 1. Can I cancel out these two? Yeah. I cannot cancel them out yet because those are not the same. 1 minus 4x is not the same as 4x minus 1. But if you remember a few lessons ago, if we have 1 minus 4x, I can kind of alter that a little bit to get something to cancel. You really only do this with the subtraction ones. So if I change the order, it would be negative 4x plus 1. Those two things are the same. That's the commutative property of addition. I can also factor out a negative 1. You could always do that. It's just not usually necessary. So if I take out a negative 1, this becomes positive 4x minus 1. All three of these mean the exact same thing. So what I'm going to do is replace this 1 minus 4x with this. But that negative 1, we want to write in the very front because we don't want it to look like minus. A little bit different. So we're going to put the negative 1 first, and then we're going to keep this 1 plus 4x, And now I can change this one to 4x minus 1. So by doing that, I can cancel out these two factors. And we have a negative on the outside, and then 1 plus 4x in parentheses over 3. Try number 5 on your own. All right, so on this one, this denominator stays the same, x squared plus x minus 6. And then in the numerator, it's a subtraction problem. So this would be x squared plus 2x because I subtracted an x, and then minus 8 because I had subtracted 1. The denominator factors into x plus 3, x minus 2. And the numerator factors into x plus 4, x minus 2. And these x minus 2's cancel, leaving x plus 4 over x plus 3. Are there any questions on number 5? Number 6, we have to carry the denominator over. 6x squared minus 5x plus 1. Does that have a GCF? What's in front of the x squared? 6. These are the ones we have to use box method to factor. Yuck. But the numerator, we're adding. So 13x squared and x squared is 14x squared. And negative 9x and 2x is negative 7x. The numerators, we can factor that one really easily using GCF. So if we factor out a 7x, we're left with 2x minus 1. The denominator, this is what requires the box method to factor. So you might have forgotten a little bit. Your A and C go in these two boxes. So your 6x squared and 1. Now we need two numbers that multiply to be 6. You multiply your A and C. So two numbers that multiply to be 6 and add to be negative 5. What are those two numbers? Negative 3, and you put an x with that, and negative 2, and put an x with that. And now you fill out the GCF of each row, or each row goes this way, I guess, and each column. So what's the GCF of these two right here? 2x. What's the GCF here? Almost. They don't have anything in common, so we would put 1. However, whenever your first box is negative, your GCF has to be negative. Now, what's the GCF of this row? 3x. And the GCF of this row? It would be negative 1. Yep. Because that first box is negative. So that denominator factors into 2x minus 1 and 3x minus 1. You're probably not going to have any of these on the test. The 2x minus 1's cancel, leaving 7x over 3x minus 1. We are going to try to get through as much of these as we can, just for time's sake. All right, so when it comes to unlike bases, we have to get a common denominator. So you've got to look at your current denominators and see what we could do to get like bases. So on number 7, we have a 2x and a 3x. What could, we don't have to multiply them by the same thing, but we want to multiply each side possibly to get a like base. So what could this like base be? Could be 6x, right? So what could I multiply the first fraction by to make that 6x? 3. So you have to multiply the top and the bottom by 3. What do I need to multiply this fraction by to get 6x? 2. So we're going to multiply that by 2. And so my new fraction becomes 45 over 6x minus 32 over 6x. Which, if we subtract those numerators, we get 13 over 6x. Does 13 over 6 simplify? No, it doesn't. So this is our final answer. Number 8. Look at your two denominators. We have an x squared and an 8x. Think about what we could make how we could get the denominators to be the same.
The left could be 8x squared if we multiply it by 8, and then the other side could be 8x squared if we multiply it by x squared.
Right. It would be really easy to make both of these 8x squared. So if we multiply this top one by 8, or the first one, not the top one, and the second one by x, that would give us like bases of 8x squared. So this would be 32x over 8x squared minus 7x over 8x squared. 32x minus 7x is 25x over 8x squared. Does 25 over 8 simplify? No, but we can simplify these x's. We can cancel out one of the x's in the numerator and one in the denominator, leaving us with 25 over 8x. Now, when we get to, we don't just have monomials anymore. It helps if you factor the denominator first. You don't really want to factor the numerator yet because sometimes it won't factor, but your denominators, go ahead and factor them because that will make it a lot easier to find your like bases. So this 5x minus 10 has a GCF of what? 5. Leaving x minus 2. This denominator is already x minus 2. So what could my common denominator be? The 5 and then the x minus 2. So this one doesn't need any changes made to it. If I multiply this one by 5, numerator and denominator, they will have like bases. So then we get x squared plus 16 over 5 times x minus 2 minus 20 over 5 times x minus 2. Remember, the denominators stay the same. The numerators, I have x squared plus 16 minus 20. What's 16 minus 20? So we negative 4. So we get x squared minus 4.
Is it possible to just work it out without factoring the left one? Like if you could determine that you could just multiply the other side by 5, would you have to factor the bottom?
You have to factor it at some point because that's how we know what we can cancel out. So it just helps. It makes it easier to go ahead and factor it from the beginning because it will need to be factored at some point in your process. How do we factor this top? The x squared minus 4. What is that? Difference of squares. So it's x plus 2, x minus 2, and then 5x minus 2 on bottom. Our x minus 2's cancel, leaving us with x plus 2 over 5. We're going to go ahead and jump to number 11, and we'll finish up there. So in number 11, we want to go ahead and factor this denominator. We want two numbers that multiply to be 6 and add to be 5. 2 and 3. So x plus 2, x plus 3. I made my parentheses too small. This fraction over here already has an x plus 2. So what could I multiply it by to get a common denominator? X plus 3. So now they're both the x plus 2, x plus 3. The left one did not need anything changed on it. So this x squared minus 5, we didn't change anything on that. This one, we have the 1, we're going to distribute the 1. So when I multiply both by 1, I just get x plus 3. So we're distributing. If that was some other number besides 1, I would distribute that number. This is addition, so we're just combining like terms. And we get x squared plus x minus 2. Are there any questions on how I got this right here? We need two numbers that multiply to be negative 2 and add to be positive 1. Multiply to be negative 2 and add to be 1. Positive 2 and negative 1. So these x plus 2's cancel, leaving x minus 1 over x plus 3. Are there any questions?